Let A is equal to ABC. What is the equivalence relation of the smallest cardinality? That is smallest equivalence relation. See, the smallest will be the same set, that is the ordered pair AA, BB, CC. This will be an equivalence relation. Can we check? Is it reflexive? Is this reflexive? Yes, because you have AA belongs to yes, BB, CC. Is it symmetric? The condition is if AB, if that doesn't exist, the condition itself is not there. If AB belongs to R, then BA should be there in R. If this exists, only then we check for BA. If this doesn't exist, we cannot prove that it is not symmetric. So it is symmetric. What about transitive? It is transitive. So this is reflexive. This is reflexive, symmetric, and transitive. This is an equivalence relation. What is the smallest? What is the cardinality? Cardinality means the number of elements present here. Name it as R here. A is a set, isn't it? So we'll name this relation as R. So the cardinality of R is 3 itself. Now, what is the equivalence relation of the largest cardinality? Largest cardinality is the universal relation. What is the universal relation? AA, then AB, AC, then BA, BB, BC, CA, CB, and CC. Anything else? Now this is an equivalent. This is reflexive. Just see whether it is reflexive. AA, BB, CC. AB is there. BA is also there. Correct? AC, CA. Then it is transitive. If you take AB, yes. If AB belongs, yes, AB is there. Starting with B, if you take BC is there. Yeah, BA or BC. Check whether it is AC is there. AC is there. Everything you check. So this is reflexive, symmetric, and also transitive. Therefore, this is an equivalence relation. What is the cardinality of this? How many elements are there? 9. What they asked? What is the cardinality? Cardinality means the number of elements. What is the equivalence relation of largest cardinality? That is the full relation. That is, this is nothing but, this is called as the universal relation. So there are 3 elements, so 3 into 3. Now the last one, in the set of integers, from the set, so from integers. Okay, we are taking from the integers. So integers, you know, positive numbers, negative numbers, 0 also. What is the relation defined here? The relation is m is related to n if m minus n is divisible by 7. M minus n is divisible by 7. So m minus n is divisible by 7, which so m minus n is a multiple of 7, divisible by 7. So we can have 0. K is 0, you get 0. If I put k is 1, 7. 7 is divisible by 7. Yes. Next put k is 2. All these are divisible by 7. Not only plus, it is because set of integers, it will be plus or minus. All integers. So it becomes plus, not only plus, minus also. Plus or minus. Plus or minus. It goes like this. So all these are divisible by 7. From integers, we are taking, this is your set A. Take it as set A. The set A is all the numbers divisible by 7. So reflexive is m minus m is divisible by 7. Take any number. 14 minus 14 is 0. 0 is a multiple of 7, isn't it? 0 is divisible by 7. Any 0 is divisible by all the numbers. So m is related to m, isn't it? It is divisible. M, the condition is m is related to n if m minus n is divisible by. This is reflexive. Oh, we go to symmetric. Is it symmetric? If m is related to n, that is if m minus n is divisible by 7. Give an example. 7 minus 14 is minus 7. It is divisible by 7. Now what about n or n? That is n minus m. See, you just take the reverse now. 14 minus 7 will give you 7. Whether it is plus 7 or minus 7, both are divisible by 7 because you are taking from integers. So minus 7 is also there, plus 7 is also there. So n minus m is also divisible by 7. Therefore it is symmetric. Transitive. Is it transitive? If m is divisible, m is related to n, and it is m minus n is divisible by 7 and if n minus something else, n minus p is divisible by 7, then if all these are if, okay, you have tried the if condition. If m, okay, if and then we have to prove, we have to check whether m is related to p. That's what we have to check, isn't it? See, m minus n is divisible by 7. That means m minus n is a multiple of 7. It can be 14, it can be anything. If I say n minus p is divisible by 7, that means n minus p is a multiple of 7, right? So what about m or p? That means m minus p, is it a multiple of 7? That's the question. You can give one example. What is m from here? You can prove from here itself. What is m? 7k plus n, isn't it? General, we just give a general proof. 7k plus n. What is p? What is p from here? P is n minus 7k. So p, if you take that aside, n minus 7k. Now you write here 7k plus n minus n plus 7k. What do you get now? 14k. 14k means what? You can write as 7 into 2k. So multiple of 7 only anyway. So m is related to p. M minus p is divisible by 7. So therefore it is transitive. So therefore it is an equivalence relation.